Hello students, I'm gonna discuss about the second unit in the computer organization and architecture. So the title of this unit is Datapath and Control. So we're gonna briefly discuss much about this datapath and control, and I'm gonna upload the video at the YouTube so that you can easily recall what we have discussed in the class. So in this unit 2 specifically, you will be having the first topic of fetching and sorting of the words, and the second one will be execution of the instruction, timing and control, instruction cycle, and then hardware control, micro instruction, and micro sequence. So first, let us see, what is fetching and sorting of the words. So let me move to the next slide. So before fetching and sorting of the words, so we need to understand about hardware components of a processor. As we already learned in the unit 1, what are the basic peripherals? So just for a recall, we're gonna discuss about basic hardware peripherals in the uh, computer. So the first most the peripherals that we need to know is the core part of an computer is the ALU. This is an arithmetic logic unit. So for this, all of the other components will try to send or support this particular component. The first one is the register file. So what is the major role of this register file? As I already told in the first unit, the register file will be used to store the datas or the one which we are trying to push to the processor to do any processing. So all these kind of informations, the data will be stored in a register, so that we are calling it as an register file. And then the second one is what? A control circuitry. Control circuitry, so I told you three important things are there in the entire organization of the computer. So one is data and control, and another one is address. So the data usually what we need to process with it, and for this particular data we need to store somewhere. So for this storing, we need to know where we are storing in the memory. So for that purpose we have an address. And the third one is control. Control is it is kind of an completely coordination mechanism where it will be instruct the other peripherals where and when to start and end. And this one is the another peripheral is an instruction register and instruction address generator, and then memory interface. So these are all the other important peripherals, so where each will be doing its job right now for the successful execution into the ALU. So in the next one, the title which I have just now gonna discuss is about fetching and sorting of the words. So in the fetching and sorting of the words, there are basically 5 stages are there. That means 5 steps that has to be followed. So what the purpose of processing is that, so you want to get the program what you gonna execute, and after execution you want to store the results. So for that there is a standard protocols right to execute. So here in this standard protocol they are just saying as a 5 step sequence always should be followed right to execution. In that 5 steps, the first one is fetching an instruction and incrementing the counter. So I want to fetch the instruction. So where I want to fetch, from where I will fetch the instruction, I will fetch the instruction from any of the memory. Once I fetch the instruction, what happens is, so immediately I want to go to the next instruction. I already told you, right? So what is a program? Is a set of instruction which should be executed sequentially. So where I want to execute the next instruction, so I want to increment the program counter. The second one is, once I fetch the instruction, So my ALU want to understand what exactly the instruction is to be. So I want to decode the instruction. So for the betterment of the understanding what exactly that instruction is given to do with the ALU. And first I will decode the instruction, and after that I will read the register from the register file. So once I decode it, so what, for example, after I'm just gonna add two values. Okay, in an arithmetic logic unit I want to put into it and add it. So for that I will write an ALL program. So add R1 comma R2 or add A comma B. So add A comma B means, so add is an function where it will do an operation of addition. So once you have written this decode, the decoding part will decode that particular instruction and it will be ready for adding it. So where this particular values will be, so that values will be where? So in the registers. For example, A and B are the registers available in your processor. So this A value, the B value will be added to the A value and stored in the A value. So that is what the basic ALL I have just told you, that add A comma B. So these are all called as registers. Okay, so these are all called as registers. So these registers will be, right, controlled, will be inside the register file. So once these two things, right, first I am decoding the instruction and read the data from the register, so that put together we call it as a register file. So once it is read, what is the next? We are ready with the instruction, we are ready with the data to be executed. So now the third step is perform the ALU operation. So what it is performed, as I said here, these two will be, right, added as per the ALU's commands. Once it is added, so where will be the data, where will be the final answer? My final answer will be in the A. So what I want to put it, so from the ALU it will be moved to what? Next stage. Next stage is what? Whether I want to read or write the memory data. So once during the fetching time it will read the data. During the results I want to write the data to the register A. So here read or write memory if the instruction involves a memory operand. So here the instruction involves the memory operand. So what do you mean by memory operand? Is there any instruction is given to move my particular data to outside of the processor's memory? So temporarily this is inside the process, that is A. If I want to move that particular value, the results, to any of the external memory, so I will be utilizing this one. So once things are ready, I want to write the results into the destination register. So that example as I have given here, this is the destination register A. I will be just trying to write, put the results right in the destination register based on the program which is executed. And here one example which I have just said before is add A comma B. So here an example it is given, it is load R5 X of R7. So what is load R5 X of R7? So load R5 X of R7 is, so I want to load the information, right, so to this particular R5. So now use the index addressing mode. So we have just already seen what are the different types of addressing mode here. So here I like use the index addressing mode to load the word from the memory location X of R7. So what you mean by this bracket? So this bracket means that there will be an address, so that from there we should supposed to fetch the information. So and then put into R5. Execute of this instruction involves the following step. What is the first step? Fetching. As I told you before, I want to fetch the instruction from the memory. Second one is I will increment the program counter, and after that third one is I want to decode the instruction to determine the operation of the what it want to be performed. And then here I will read the register R7. So add the value immediately, right, and then from the right content of R7. So now what happen is some x plus R7. So what is inside the R7 will be added to this particular x. Right, that is what an effective address of an operand. And after that, load the data received from the memory into the destination of the register. Once I add it, and then the data will be loaded to R5. So basically, this particular case, right, fetching and execution of the instruction above can be completed in the following 5 stages. So put together, I told you previously, so there are 5 stages of this process, fetching and sorting of the word. Stage 1 is fetch the instruction. So that is what stage 1, right, that is fetching the instruction. And increment the program counter. Increment the program counter. Stage 2 is what? Decode the right instruction and read the content. And the third one is what? Execute it. Where the execution has happened, it is in the ALU. And after execution, you will get the result. You want to access the memory. After accessing the memory, you want to write back. Means write the results. So that is what compute, read the right memory operand and load the memory operand. So these are all the the very important 5 stages of what instruction execution and fetching of the information. Right now, let us stop here, and I will post the ALU register file connection in an upcoming video. So thank you for your patience.